You could do anything with it. I actually missed out. Make sure you unmute yourself. Trevor's laptop doesn't have enough ports, so I connected my laptop and then there was issues.
Go ahead and get started now. Hello, everyone. Right. Well, my name is Trevor. If you don't know, I'm the program officer at the Society of Software Developers. Yeah, and I'm going to talk about the types of software that you typically see in like a network engineering team. It's like the software that they typically interface with. There's really three kinds. You've got like some sort of virtualization software like VMware. You've got like an operating system, obviously, and then some sort of like network management software. There's usually like several different types. So like here's like a kind of like a, it works like layers. Networks are like folders. But you've got like the network, and the network is made up of a lot of things, but you think of it as just a bunch of routers. And then the routers are going to run some sort of virtualization software. They normally do. And then we'll go over like a piece of software. And then I'll just go over an example of the types of software that you typically load into virtualization, like VMware. So I'll briefly just like the network and the routers gonna be like quick. So first, ignore that like diagram. All you need to worry about is that the network is just a bunch of routers. And then you've got like a cell phone tower that connects to the router, like the network next to some router. And then you've got like these custom routers. So there's a bunch over here. I feel like I should.
Does the camera turn?
Oh, does it?
Yeah.
Oh my gosh. All right. So yeah, you've got, so like at Verizon, which isn't necessarily like you can either rent a router from Verizon or they'll have their own. The Google router is called it's the one that like all the routers. And then the router, so here's like the one that I interacted with the most. It's a Juniper Mx2020. It gets its name because it has, should I turn the sensitivity?
Maybe you could just say,
Okay.
you use the mouse to.
Oh. Okay. So it gets the name because there's 20 NPCs, which are multi-port card slots. There's 10 on the top, 10 on the bottom, and it's just a big computer. That's pretty much what it is. It's x86 architecture. It's got two routing engines. So there's one on the left, one on the right, and that's what stores the configuration of the router. So how the router is configured. If one fails, the other one will take over. So the one on the left is known as RE0, the one on the right is known as RE1, and when the router is normally operating, RE0 will be the master router, and if the master fails, then the backup will take over. And then Juniper provides software for these routers called Junos. And this photo to the right, it was hard for me to like find photos of this router, but you can kind of hear it. Is it blocking? But you can see there's an MX2010. Guess what? It only has 10 MPCs because it's shorter. And you can see there's some slots in use.
If you wanted to, could you run like stack?
Yeah, you can run Windows on these. You can install anything. I definitely installed Windows on one of them without telling anybody. But just
What is
that's a multi-port card slot. So we can install a network interface card, but you can also install something else. Like it's for like used for multiple purposes. It's not like preferred. It's just this particular machine. It's like it'll like have some sort of AMD or Intel something.
because Junos runs on it?
Junos is just the Linux distribution for Juniper routers. And so the major problems that we've run into on these routers, the major issues we run on these routers are with configurations, and those are typically what bring networks down. Facebook, and the most crucial point of a router after it's been installed and configured is during an upgrade. So we follow this kind of basic outline. It won't be the same everywhere you go, but it will kind of follow this general set of rules. And it's called a method of procedure. So each company will have its own method of procedure for each router. So for Mx2020, Verizon's method of procedure is 101 pages. I don't know why, but you can kind of condense it down to like 2 pages of like what you actually need to do. So first thing we do is we run pre-checks. Those are just a list of commands that are like, hey, what's my IP address? Or something like that, just like a bunch of information about the system. That's what you're getting. And you're gonna save that into like a text document or something. Then you're gonna deactivate the recovery services. So if a router fails, like I said earlier, if a routing engine fails, then the backup will take over. So those services that monitor like when we should switch over is known as non-stop routing and graceful switchover. We have to deactivate that because it'll get mad at us if we like try to like shut down a routing engine while those services are like monitoring it. So we turn off non-stop routing graceful switchover, and we upgrade the backup because the backup does not have any traffic on it. You don't want to upgrade the master because that's got traffic on it, and like if that goes down, like you might have issues. So we look at it. We're like, oh hey, it's like actually running. It like didn't blow up. So we're gonna try to switch the master, which means now RE1 is the main router. RE0 is now the backup. And if it still looks good, like we still have traffic flowing through that router, then we're gonna upgrade the master, and then we're gonna switch it again. And then guess what? We switch it. So now RE is the main router. RE1 is the backup. And now both routing engines have been upgraded. Each routing engine is kind of like a computer. Let's think of it like that. Each one's going to have its own configuration and its own operating system, like Junos. And after so we have to reactivate our recovery services, which is a non-stop routing graceful switchover. We run post checks and then we get a diff. I'll show you an example of a diff in a minute, but I'm going to cover something really, really quick. So a diff is essentially just like, what was the difference? What happened, like, when I upgraded this router? Like, it's going to show me, like, the diff. Let's get that, like, get that as diffs. I think it's what it is. So, like, there's a lot of security involved when we deal with this because we have, like, millions of users, like, using the network every day. And one thing, so obviously there's security protocols within the network itself, but then there's security protocols with the actual design of the network. It's more like it's not written in code; it's just practices, I guess. And I mean, if you can imagine, Verizon has all of these like really detailed schematics and designs and plans of their network, and if those plans were to like get into the wrong hands, that might just be enough information for someone to launch some sort of design. So not only is it risky, but it's actually illegal to send like plans of networks outside of the country. So the thing is, Google Drive doesn't like let us control where our data goes. So Verizon has to use one. So because the way Google Drive works is like caches and it like sends data just everywhere. Whereas like OneDrive is a little bit more controlled, and we can like tell Microsoft like don't send this data outside of the country, and that's just legal stuff. But yeah, Google Drive bad, OneDrive good. We also have to be careful when we're like sending information over email because a lot of people within the company might use or might use like Gmail. Other people in the company might use Outlook. If you send someone a very sensitive document through Gmail, that's another thing you have to watch out for because obviously Google's going to use that same kind of scheme where it's just like, oh, it's gone. It's in some country and now you're being sued by the federal government. So yeah. So routers will run some type of VM software. Usually, you don't have to have VM software, but without it, you can only run one like piece of software. So, and if you don't, that's usually Junos in this case, because that's the Juniper routers. That's what they run. Like Cisco routers will have their own operating system. But we need a VM, like we need a VM for the, or we need virtualization software to create VMs for, and we'll have one for DNOs. So it's kind of like, you guys know what like open box or VirtualBox is. That runs like in Windows, and in this scenario, it's like reversed. It's like the operating system is running in the like the virtualization software is the operating system, and then the Junos runs inside the virtualization software, not the other way. And we can, the benefit of doing this is like now we can like create more VMs for like network management. We can create a virtual machine for Minecraft. Like, we can really do whatever we want once we have like VM software. And there's two different kinds that are like mostly accepted or mostly used. So one's OpenStack, and how that works is it runs with Ubuntu, so you have to like install Ubuntu on the server or some sort of Linux, and then you install OpenStack. It's comprised of like multiple pieces of software. It's really icky. Like you need to do a lot of configuration. It really doesn't do anything for you. It's all command line based like stuff. It does have a GUI, but it's also icky. So I switched to VMware after I realized OpenStack was just awful. It takes care of everything for you. Like when you install it, it installs like Windows. So you have like a boot USB, you just go up to the big old server and then you install it. Yeah, it's like not even buggy at all. I don't know why I said less buggy because it's not buggy. It's oh yeah, and another thing is like resource pools. So when you have like VM software, it needs to know where it's getting its IP addresses from. And so when you create a virtual machine, it's going to assign an IP address. OpenStack doesn't like it when you have more IP addresses after you've created like set everything up. But VMware does. You can also add more resources to the cluster, which, without getting too detailed, a cluster is just multiple servers pretending like they're one server, and then all their resources are shared. So in this screenshot, in this screenshot, this was actually running on an Mx2020. It's kind of blurry, but if I were to cluster another server onto this instance of VMware, it would essentially double the resources, because right now I'm just on one, but if I added another one, it kind of makes things cleaner to an extent. Right, I'm gonna demo the stuff now. But I'm just gonna show how we would deploy like a virtual machine inside VMware ESXi. Because once you get it, like installing it on the router and everything is literally easier than installing Linux, because it like doesn't ask you for anything. It just is like, oh, there it is. And but like actually creating a virtual machine is a little bit more involved. While I'm waiting for the boot, I'll start talking about this. So the software is kind of weird. It's not like how we think of software on our computers. The software can be, well, it almost always is split up among multiple virtual machines. And like, just think of a virtual machine as just like a computer. So a single piece of software could easily run on, or require at least like 4 machines. So here's like, you look at the top of this list. So there's a piece of software called Atom, and that's the one that I'll be going into more detail later. But Atom requires 1 master node and 3 worker nodes. And so what I'll do is I just go into like, you have like a Google Sheet of just all the available IP addresses, and then I'll just like mark them as used. Like I'll just take a bunch of IP addresses that are like free, and I'll say, these are in use now, and I'll take them. When I'm deploying Atom, I'll go through, I'll set up each worker node, and I'll tell it, this is your IP, this is your IP, this is your IP, and then I can actually access it using this guy right here. So the other ones you access them differently, but for Atom you access it using this port. So you give it the IP address, you give it a port, and you just plug that into like Google Chrome, and it just loads up. Like the software, almost all the software like runs in a browser. So you just type that IP address into like a browser's address, and you get the graphical user interface. It's right there, and then it works. And you log in. You would set the credentials when you're like deploying the software, but when you're installing it. So it makes it really fluid to just kind of like say, I don't like this software anymore, and then you can just get rid of it without it affecting Junos, because it all revolves around security, and you want Junos to be isolated from anything at the end of the day, and then that way I know if I want to delete Atom, I know that it's not going to like, or if I want to add Atom, I just know if I'm going to deploy software or get rid of software, I just know that it's not going to affect the routing at the end of the day. Let me presume to launch. But I have to this. Eric, can you email me the Zoom link?
I have the this
Okay, okay. I could just like show it. Um, Zoom is not launching. But I was thinking I could just well, it maybe Zoom will launch eventually, but right now it's not. So okay. So let's talk about Atom. I mentioned Atom earlier. It's one of the several pieces of software that we can do, or several VMs. Is it quiet? Can you guys hear me?
Is this one better? Okay. Okay, cool. So Adam, so I mentioned earlier methods of procedure, and it's just a list of steps that we take to complete a task. And we can use Adam to automate that kind of in a way. We can just tell it to just run these commands in this order, and we can, and if things happen, we can also take paths, and it's essentially like it's a flow chart. That's the way to think about it. It's a program flow chart. And so yeah, the cool thing about that is that like if, for example, BGP were to fail, which is like a protocol on the like the routers use, it's if it were to fail, Adam could detect that and then run our like BGP, troubleshooting workflow, our method of procedure that we turned into a workflow. Oh yeah, and I also mentioned Paragon. So Paragon was another one that was on this list. You see a bunch of Paragon software here. Paragon is really cool because it uses like past behavior, and it also analyzes like the current configuration of the network to predict future network failures. I'm not sure entirely how it works, but it can actually just perform like preventative actions. Like it can reconfigure the network. Like, of course, you have to like approve it, but it'll like fix the network for you if you're like dumb and you like don't know how to do network stuff. So yeah, now like for some code stuff, which is cool. So when we create an Atom workflow, we'll kind of construct this thing here. Like it's really just drag and drop. These big boxes are called tasks and these little circles are called events. So a user task is like a form. It's something that the user has to complete. And in this case, the user would be a network engineer. And then a service task interacts with Atom's API. So Atom, another cool thing about Atom is it has an API. So if I had a piece of software that I wanted to like do some like interact with Atom, like, oh, if I could set up Paragon to where like if it detected some sort of alarm and within the network, it could run this Atom workflow using the Atom's API. And then within a workflow, we could, let's just say right here, this, let's just pretend like this run pre-checks. Let's pretend that we, in our user task, we gave it a list of pre-checks. So show BGP, I think, is a command that is valid in Junos, I believe. And it'll show the configuration of BGP. And within this run pre-checks, we'll use execution as like so we'll use a script like this. It's pretty short, at least for this one, but we use execution, which is like the context. That's the best way to think about it. It is the calling, it's like the router. And from the router, we can say get the device ID. Simple enough, right? It's an object, and this is written in Groovy, but you can also use JavaScript or Python. So I mean, it'll literally run whatever you give it. So I mean, if you like try to do web scraping in Atom for whatever reason, you can do that. But after the way Atom interprets this is once you've finished execute like your lines of code, I guess, you're going to give it some sort of something within like a string. You're just going to write a string at the end of your body of code, and it's going to see that, and it's going to say like, oh nope, it's going to see that. It's going to say the Atom API is really well documented. It has outlines of how you do this stuff, but for just running a command, the bare minimum that you need is you need to give it the device ID, and you need to give it your command. And it takes this kind of like HTML format, and it will run that command on whatever router is in device ID. So whatever router you're running this workflow on, it will run that command on. That's like the most simplest form of what's going on here. And another, and the last thing is a script task. Script tasks don't interact with Atom's API. We're just running scripts. So here I imported just some utilities, and then I'm using the get diff utility to get a difference between the pre-checks and the post-checks using the execution. But you can see there's no string, there's no like HTML formatted thing at the end here. It's just running a function. And then of course there's events, which are like start events, which is like this guy, end events, which is here. And then we have these things called error boundary events, which is like a catch block. So if it tried to run our command and the command failed, it could inform the user, or it could take a different path to maybe try to fix something using, because you can analyze you can gather the input or the output, I guess, from the router, and you can be like, oh, it says this, so I'm gonna go do this. Like I'm gonna try like different things. And I've seen some workflows that are just insane, but like 1,000 tasks. But here's an example of the diff function that I mentioned earlier. Yeah, it just gray means no difference. Red means before, blue means after. So the ones you're looking at here, I upgraded a router from the same version to the same version. So like, I think it was like Junos 20 to Junos 20. So yeah, the only thing that changed was like these timestamps, but it kind of shows you like what it does. And then the last thing here, wait, what was the meeting ID? Right. Here. 428. Okay. Sweet. The last thing here is a workflow. This was kind of like I made this one, but it looks big, like long. It's not long. Some of them are so long. Like I had people criticizing me for how short this was, but it is the same thing that I showed you earlier. It's this. It's the basic outline of upgrading a router, just in the form of a workflow. And I know it's impossible to read because for some reason it's blurry, but and unfortunately I can't go back and re-screenshot it. But essentially, first task is a user task. It gathers user input. What router are you trying to upgrade? Where is the image stored? Because you have to have what's called an image server, which is hosting, which has the upgrade image, like an ISO essentially. Then it's going to try to run its pre-checks. If that fails, I've got a little thing here to cover some cases. And then we're going to deactivate nonstop routing and graceful switchover. And then this whole line here is upgrading the backup router. So these first few steps are copying the image over to the router, and then we're going to upgrade the backup. We're going to wait. This is a timer. I think the method of procedure called for 5 minutes. And then we're going to see, what does this say? I think this just makes sure that it's running. It just runs a command and makes sure that like the router is responsive. And I just assume that if it can take a command, then it must be working. Sure. So I do the graceful switch over. Then I'm like, okay, cool. So now backup is routing our traffic. Master is now being upgraded. It works. Sure. Do the graceful switch over, or like turn on nonstop routing and graceful switch over. Of course, we switch the master and the backup again. Turn on graceful switch over and nonstop routing. I'm getting myself mixed up, but it's the same process, just kind of dragged out a little bit. And then we get our post checks here, and then we get a diff here, and that diff is the same diff here. And then I also have a catch. Well, it's an error boundary event, but it's going to catch it's going to catch any error really. If it tries to run a command and the server says no, or the router says no, Adam will be like, oh, hey, it said no. And so it's going to go into here. I have it set up just where it tells the user, we're going to roll back. And the user just says yes. If the user says no, we don't roll back. The user says yes. I just run a few commands here to like kind of undo some. So a rollback is just undoing what we already did, getting it back to the original state because the upgrade failed. Let's see. Okay, well, Zoom failed to connect. So if I can get it to work, maybe I can show it later. But we're on to the next part, I guess. No.
Okay.
No.
All right.
Yeah, that's the end of my presentation.
All right, so hold on. Yeah, so I have a couple announcements. So while I give those, maybe you can try to get Zoom working. All right, so we have So December 8th is the season finale for SSD. We're bringing back lightning talks. We're gonna have a special election for the outreach officer. And it'll be a time to give feedback for this past season and the next season of SSD. So we have an open position for outreach officer. We usually do elections in April, like the end of April. But you know, the current outreach officer, Varun Puri, if you know him, he's graduating this semester. So so basically, like, we're gonna have an election. So the outreach officer, they're responsible for managing communications, presence, outreach, social media, and interactions with external organizations. So basically what that means is like, you know, I'm like the president, but sometimes I'll ask the communications officer to like write an email for me because he's a lot better at writing emails than I am. They'll head up marketing efforts. They reach out to other clubs, companies, professors, anyone who might be able to talk at SSD. Yeah, so if you want to run, just send an email to our ufssd.org@gmail.com. Declare your candidacy and yeah, write a short personal statement, like a short paragraph saying why you should be outreach officer, right? Yeah, so if you're not familiar with Varun is our current outreach officer. Like he just decided that it would be cool to graduate this year and also take on 2 research projects. So he hasn't really been coming to meetings, but it's fine. Like he was the president last year, and before that he was the treasurer. So Varun has been a really long-standing member and a supporter of the club. So thank you, Varun. You're not here, but thank you. He helps the club pull through COVID. So yeah. Lightning talks. Another thing we're going to do during our end of semester celebration is lightning talks. So basically, lightning talks is a super casual and fun thing. It's a time for you guys to give a talk if you're interested in. So in this picture right here, this is a picture of me in fall 2019. Yeah, fall 2019. That was the first semester that I was with SSD. And the president at the time, Blake, he announced lightning talks, and I was like, oh, like I have something that I really want to express, right? And so I gave a talk called "Why MATLAB is Terrible and Bad." So it doesn't have to be a serious thing. Although if you want, you could give like an informational tech talk. Like Blake said that he plans on giving a talk on his programming language Rovas. I plan on giving a 5-minute talk on why JavaScript is dumb and stupid. I know some people in the past have demoed projects. So it's a really cool way to give back to the club, gain some personal public speaking experience. Yeah, so if you're interested in this, I have this QR code to sign up. I'll post a link to it later on Discord, but so I'm giving a talk, Blake's giving a talk. Anyone can give a talk, but I'm looking to get like maybe like 4 or 5 people in on this. At least, you know, the more the better, right? Because it's not like a serious thing. It's just whatever you want, right? Yeah. Also, reminder for next week. Next week is the speaker with Google Cloud. We're gonna have someone from Google Cloud come here in person at 6:15. He'll go over the daily life of a Googler, resume tips, and an intro to a Google Cloud platform. There will be pizza as well. I'll post more about it later. All right, Trevor, how's it going?
So, EDU room just kicked me off. Oh, no. So we're moving back steps right now. But, oh no. So I guess we're not doing the thing. I mean, I could like just demo it to people.
Oh, yeah, well, yeah, so, okay, Nathan, I'm very, very sorry, but you won't be able to see this, this demo, because Trevor can't get his laptop computer to connect to Zoom. So, yeah, I mean,
I could just like put it in front of the camera.
or maybe what you can do is you can like just maybe you can just record it and then we'll put a recording on it later on Discord.
Yeah.
Yeah, okay. Yeah, so Nathan, if you're interested, you can watch a recording for this later. We'll post it on Discord. But yeah. Okay.
Thanks. Thanks. The thing is, I'm like still in that situation where like I have this and like this. So I don't know if I can plug this in like.
Or you can just, I guess you can just kind of turn your laptop towards us.
Yeah, that's true. Well, so it's like the wrong end. It's like it's this guy, it's this cable, but then it goes in there. And then yeah, it's just like in the abyss. But I could still try the camera method. Right. Let me just take it. Thanks. See, let's pin this. Wait, do I have to stop screen sharing first? No. Okay. Awesome. So here it is. Yeah. Oh God.
You want me to hold the camera?
Yeah.
All right, guys. Shout out to Nathan for being the most patient person on earth.
My keyboard. Oh, there it goes. I just saw it light up. Why is it? I think I'm stuck with touch controls. Like I said earlier, this laptop's a little broken. And also Zoom hates me, I guess. But so this is typically what you would see as like a network like administrator working in like the lab, and you typically would have more resources than this, but this laptop only has like 4 gigs of RAM, so, or this tablet even, but it typically you wouldn't be accessing this user interface from within the device that VMware ESXi is running on. The only reason why like this is working is because I have Windows, but you would usually log in, you would usually like have your company laptop and you would just like type in the IP address and then you would be accessing the router from your laptop. And so let's just pretend like we're creating a VM. So you would click on that little button that says like, I don't even remember what it said, create or register a VM. And typically when you're deploying like software like Atom, you get an OVA file, which is literally just the virtual machine kind of already set up and deployed. You just need to like import it, in which you would choose this option. Or if you just had like an ISO, you would just create like a new machine. Then we can say, and it's Linux. And we'll just choose Ubuntu, because everyone knows what Ubuntu is. Oh wait, it needs a name. They'll get mad at me. Hold on.
Greg.
Yeah. Wait. Sus. And then so this is VMware has this thing called data stores, and it's so I'm trying to think of the best way to explain it. Routers have a lot of hard drives, a lot of storage, mostly like for the routing table and like its configuration and all that ton of stuff. But then it's got like another like virtual. The routers that I worked on had a really whack like partition, like because over the years of people working on them, no one ever like reset like the partitions. So like there was just like these like little tiny like 1 megabyte partition. There was like so many. It was just weird. But our data store is kind of like a virtual hard drive. That's the way to think about it. It just takes a bunch of hard drives or something like that, SSDs, and puts them together into one data store. Or you could have like multiple data stores on a single hard drive and just have like the data store be smaller than the hard drive, but for this one, we just have one. And when you're setting it up, you'll have like, it'll ask you like how many CPUs you want. So like a router, the MX2020s have 28 CPUs. And you can just, you literally just, you're making a computer. Like it's literally what you would expect. And I'm not going to deploy it, but we would upload our image to VMware. So the image of our software will at that point be stored on the router because that's where VMware is installed. And you'll see it. I mean, you can see there's a little upload button right here. Is that like actually showing up? I don't know. But you would upload it and then it would just, yeah, it's a file explorer. I don't know. And then after you've deployed your VM, I'm not going to deploy one because it takes like a minute, but you'd see I've already got one set up here. You can just kind of, yeah, help. I call this VM help. I used an Ubuntu 18 image, and you can see it's telling me like how much resources it's using. And that's another cool thing about VMware ESXi. It's very fluid. Like it has like 2 CPUs or whatever that means. But you can see right now it's only consuming like, it says 251 megahertz. So how it works is it will take all the CPUs and it will just add all the physical CPUs in the server, in the router, and it'll add all of that power together and just kind of represent that as just like I think like for the Juniper Mx2020, it was like 67 gigahertz or something like that. And then effectively it lets you have more machines than you have resources for those machines. So like Ubuntu says, oh, I need a 2-core CPU. So you would allocate 2 CPUs to it, but then you could theoretically have more than that because it's never actually using all of those resources at the same time. But yeah, I don't know if this is gonna.
Virtual banking for CPUs.
Yeah. So I wanted to install Ubuntu server, but I realized that we're gonna have like a lot of problems trying to SSH to it, and yeah, yeah, there you go. I just installed Ubuntu desktop, but yeah, that's it. That's the actual like machine running inside VMware ESXi. This is not an ideal use. Typically, you would SSH to it. You would like get onto a PowerShell or something like that, and just like send commands to it that way. This is known as a virtual console. What you're looking at right now, it's obviously not a console because it's Ubuntu desktop, but it lets you, use the VM if you are having problems connecting via SSH. Yeah, we can shut it down too. Okay. I don't know if it's actually going to do anything. But yeah, okay.
All right. So that was the demo. Epic. All right. Thank you all for putting up with our shenanigans and this technical difficulties. Once again, I hope to see a lot of people in here next week for a Google Cloud thing. I kind of want to impress Google Cloud, but yeah, hope to see you guys next week. And yeah, epic.
Answer honestly, did I bore you guys? Okay.
Except when you were figuring out Zoom.
Yeah, sorry. It just said can't connect. I'm like, I don't know what that means, bro. Like, then edu room kicked me off. Maybe that's why.
Why is it looking at my
Like, it's not
camera?
like you just play her guns.